Alright guys, welcome to lecture 9, which is about stargazing. In this lecture we're really going to be reviewing what we've learned so far. There's going to be intermittent video, which we're going to be doing part of what we're supposed to be doing in this together, and I'm going to show you how it works in real life. Alright, remember what we learned last lecture. To find maximum altitude, you need to have the celestial equator. And in order to then go further from there, you need to add your celestial equator to your declination, giving you maximum altitude. And celestial equator is determined based on your location relative to the North Celestial Pole, basically your latitude. So if we are located at 30 degrees from the North Celestial Pole, our celestial equator is going to then be 40 degrees. And our declination is 0, hours. Now let's take a star. We're going to, star X has a declination of minus 16. Let's find the maximum altitude. Maximum altitude, again, is equal to celestial equator plus declination, which means 40 plus negative 16. This is going to come out to 24 degrees, and that is the max altitude for this. So now let's find the azimuth. Okay, remember, if your maximum altitude is less than 90 degrees, that means your star has fallen on the southern half of the celestial meridian, or 180 degrees. And if your maximum altitude is greater than 90 degrees, that means it falls on the northern side or has a azimuth of 0. In this case, our maximum altitude is less than 90, and so our azimuth for this star is 180 degrees. Remember, stars will reach the maximum altitude when on the celestial meridian. The celestial meridian is the middle of the sky, just like we learned last time. Only north is 0 degrees and south is 180. The size of maximum altitude determines the speed of rise and setting of the star. Fun thing here. If you have a larger maximum altitude, your star will actually move across the sky slower because it's closer to your zenith. The smaller the maximum altitude, the closer it is to horizon, and so the faster it will move across the sky, and it is more likely to be obscured by an object on the horizon, meaning the observer has a much more limited opportunity to see it. You have two types of horizon in this case. You have the ocean, which is type 1, and then you have type 2, which is your mountain range and trees, which has the higher ability to obscure, whereas your ocean view, your oceanic horizon, is very clear. When a star has a maximum altitude of about 10 degrees when in our location, or in general, depending on where you are, in general, when a star has a maximum altitude of about 10 degrees, it will take 6 hours for it to cross the sky. That means rising and setting. If the maximum altitude is 40 degrees, your star is at the celestial equator itself, so it will take exactly 12 hours to cross the sky, rise and set. The stars at the North Celestial Pole will always be above ground, and these are known as circumpolar stars because as long as they are in the northern hemisphere, they will not appear to actually move, or they will only appear to kind of circle around your head from your perspective. Okay, so the local time of a star is very important. It's how we know when a star is going to rise or set or pretty much do whatever a star does. We tend to tell time and our days and our months, etc. by the solar day. The solar day is exactly 24 hours. It goes from noon to noon. So it starts at noon and ends on noon the following day. But then we get the sidereal day, which has to do with Earth's rotation. One Earth rotation is at not actually 24 hours. It's 23 hours and 56 minutes, meaning it's 4 minutes earlier each day, and in 1 month it's 120 minutes earlier. The sidereal day is part of why in different seasons we have different stars. It's also why we have leap years. So in day 1, the Earth is, and here's our little person again, we are lined up with the noonday, the sun, and a distant star. In day 2, 11:56 a.m., just before noon, we have only the star overhead lined up with this little person. We have not yet realigned with the sun, which is what we want. So at noon, we have now turned one time with respect to the sun, but has made more than one turn with respect to the star. This is the Earth's sidereal day. So we've talked about this before with the moon. Again, it's the same thing. It's the realignment with the sun and a distant star, but in this case with the Earth. So in this case, we have to do a little bit of an extra turn in order to get to the sun. And that little bit of extra is the sidereal day. So the solar and sidereal day will actually determine the time a star will rise to its maximum altitude. So please remember, the maximum altitude is going to be along the celestial meridian, both north and south. It is not going to be along the horizon. That's when it is starting to rise. We are talking about when it's on the highest point, the celestial meridian. And this is really important, so you should make sure you remember this because it will be on the exam. I believe there's a question about this in the study guide. Let's start with a declination of 0 to 30 degrees. That means from the horizon to about 30 degrees up, it's going to take you about 4 hours to rise and set as a star, if you were a star. From 31 to 60 degrees, it will take a total of 6 hours to rise and set. And if it is greater than 60, so from 60 to 90, it will take 10 hours to rise and set. Once we reach the North Celestial Pole, however, remember, these stars don't actually rise and set when we get to the North Celestial Pole. Okay, so we're going to pretend that's the North Celestial Pole. Stars on the North Celestial Pole will just appear to rotate in a circle around our heads, never rising or setting. Using this to determine that, you can actually find the right ascension of the sun for any given date. So right ascension meaning this is what you're going to use in order to find out when it's going to be highest in the sky. So the right ascension on March 21st is 0 hours, then 2 hours, 4 hours, 6 hours, 8 hours, 10 hours. This is important. This is important information. You'll notice here it's jumping per month, right? But we are jumping 2 hours each month. So if the RA of the sun is about 21 hours in this case, we have 20 and 22. At 21 hours, we are right smack dab between January 21st and February 21st. Okay, this is very, very, very important. That means that Friday, let's say February 8th, we're pretending it's Friday, February 8th, the right ascension of the sun would be 21 hours. That means from the 8th to the 15th of a month, because we're not going to do the complicated math. There is complicated math breaking this down. We're not going to do that. We're just going to say, on average, from the 8th to the 15th of any given month, you will be that middle number. So September 8th to the 15th will be 13 hours. October 8th to 15th will give you 15 hours. Okay, does that make sense? This is something I need you to remember. This is something I need you to memorize because this will be on your exam. You will have to figure out a middle number. Anyway, so we can make a chart using these times. We can take the date or around a said date and use the assumed right ascension in order to figure out noon and what time then a star should rise and reach maximum altitude, which is really nifty. So the sun will reach its right ascension, 21 hours, at 12 p.m. If the sun has a right ascension of 0 hours, it will meet that at 12 p.m. This is the start and end of the solar day. We can use this to determine the time for a star's maximum altitude based upon its right ascension. Maximum altitude is based on its right ascension, so the sun's max altitude will be at 12 noon every day. If a star has also a right ascension of 21 hours, it will also have reached max altitude at 12 noon, so we'll never see it. By the time night falls, it will be closer to the western horizon. So this is a chart created based on the sun's right ascension, which we can use to determine the time of maximum altitude for any star we see in our sky. I suggest you make note of this, commit it to memory type thing, because it will help you later, I promise. We can use this chart to then determine the time of the following stars' maximum altitudes. I want to briefly explain how this ends up working, because right now you can see on your screen, it just says, oh, we are at the 21-hour mark, therefore we're going to start at 21 hours. And I know this is a difficult concept, especially in an online lecture. So we are saying our imaginary date for today is the 8th of February. The 8th of February, being between the 15th and the 8th of a month, allows you to fall directly in the middle, allowing you to be the 21-hour mark. So we take this and we say, okay, this is when the sun will hit noon, which is the beginning and the end of a solar day. So that means we put right here, it says RA. This is the RA. We are at 21 hours, so we are going to start at 21 hours. And we will go forward from here, going 21, 22, 23, 24. You can actually start 24 at 0. It's optional. Okay, either are okay. And then you're going to go back to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And then you go back to 21. So 11 a.m. is 20 hours, 12 p.m. is 21. All right. This is how you figure this out. So if we were to choose a different date, we would be able to start it from there as well. So let's take an example of maybe our date is in fact January or May 21st, for example. Let's say we're on May 21st. Okay. We're going to have a difference here. May 21st is no longer going to be 21 hours because May is just a couple months after March, and March is our 0 hour mark. Okay. So let's give it a go with that. Now we're back at our stage. So now we're going to say our date is actually May 21st. Well, May 21st is going to be 4 hours. That means instead of starting at the 21 hour mark like we did last time, we are now going to start at the 4 hour mark, which means if we come down here, instead of 21 hours being our 12 p.m., 4 hours is our 12 p.m. and we will go from there. And remember, this right here, this right ascension that we're looking at consistently is when we are going to reach noon for the sun. In this case, 4 hours is when we'll hit noon. Means when we come down here, that means our day now starts at the 4 hour mark. How do we use this? That's what's important. If we have the sun at 21 hours, the RA is 12 noon at 21 hours. So now we're able to determine the time of a star's maximum altitude. We are going to say you have the star Yo, right ascension, 21 hours. Declination plus 30, meaning it's positive. It's in the northern the northern side of the celestial meridian when it reaches its maximum altitude at 70 degrees. So we know 3 things. We know maximum altitude, declination, and right ascension. This is when right ascension becomes important in all of these problems. So in this case, that thing that we just wrote down is going to become very, 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 very important. Now we are going to be using that 12 noon again. So remember, 12 noon right now, since we're on February 8th, is going to be starting at 21 hours. Now let's give this a go. All right, so let's start with star Yo. Star Yo has a right ascension of 21 hours. Its declination is plus 30. It has a maximum altitude of 70 degrees, meaning it's about up here, right near the zenith. So it's got about a 10-hour rise and set going on there. So now what we need to find out is, well, when will it actually reach that maximum altitude? What time will it be? So let's look on here. We are starting, remember, it's February 8th, so this is noon. It is the start of the solar day. And so we're going to be, okay, so 21 hours, 21 hours. Oh, interesting. That means the time that we will be reaching maximum altitude will actually be 12 p.m. or noon. So now let's do it again for star Xing. Star Xing has a different right ascension. This one is a 22 hour. So if we were to look at that, we would start it here. 21. Oh, look, 22. This is when we have maximum altitude for Xing. What time would it be? Based on the fact that noon starts at 21 hours. 22 hours means we are leading to 1 p.m. That is when it will be at maximum altitude. So on the celestial meridian, it would probably be at south at about here. Remember, 30 to 60 degrees, we're having a 6-hour rise and set. So it'll take 6 hours for it to go through its whole cycle. But by 1 p.m., it will have reached maximum altitude. if we were to do this again with the previous understanding where we were going from May instead. Okay, so remember, today now we're going to say we're on May 21st. May 21st starts at 4 hours instead. So we are changing the fact that noon is at 21 hours to 4 hours. Now let's go from here. Now we look at Yo. Remember, it is springtime right now. It is close to, we're almost in June. We're almost to summer, but it is springtime. So January to February, you're in the middle of winter. And we're not seeing Yo, we're not seeing Shin because they're going to be at their maximum altitude right smack dab in the middle of the day for us. But now we're going to have a different story. Now we're in spring. We're going to see something very different. So let's start with the right ascension for Yo, which is 21 hours. So we start at 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 hours. At this time, we are going to be at our maximum altitude of 70 degrees at 5 a.m. This is right before the sun rises. We will have the darkest sky. You'll be able to see it right at its peak. So remember, 70 degrees is actually kind of high in the celestial meridian. It will take 10 hours to rise and set total. So it will reach its peak at 5 a.m., which means it will have set by 10 a.m. Now let's look at Xing. Xing's at 22 hours, and we already know 21 hours is right here, so 22 hours is over here. So Xing, again, we wouldn't have been able to see it, will be up at its highest point at 6 a.m. Again, this is right before the sun is starting to rise, so we will be able to see it or not. It depends on where you are in the United States, how cloudy it is, obviously. But it might just be starting to get light on the horizon. Most likely not until 6:30, but you should still be able to see it. If we were to go earlier, such as March, or later, such as September, it may show up exactly around 10 p.m. or midnight, which will be a little bit better for us to go out and see because, plain and simple, not all of us are up at 5 in the morning to go out and go star searching. But you can see how depending on what time of year we're in and the date depends on when we're going to see stars in the sky. And that's what makes this super cool and very important. The sun has a right ascension of 21 hours. It will hit its max altitude at 12 noon. Therefore, if you have a right ascension of 21 hours, the max altitude of said star, like we just saw, will also be at 12 noon, versus 22 hours will be at 1 p.m. So remember, we went over this briefly just a second ago, and then we changed the date to C. If you have this reference sheet, okay, in front of you, and I were to say, okay, here's a date, go ahead, fill in the reference sheet based off this date, which means if it's March 21st, your 12 noon will be 0 hours, in which case you will say, all right, I have made the sheet. Now you can give me a right ascension and I can tell you what time that star you just brought up should be at its maximum altitude. It's fairly simple. Once you do it a couple times, it becomes even simpler. Do not look at this as a scary thing. This is going to be something we're going to be using in lab. This is something that we're going to end up doing on the exam as well. So please, 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 please make sure you review this. If you have questions, I'm more than happy to do this a couple times with you in class as well. Star maps. Star maps are neat. This stuff all does lead up to star maps, like the fact that we were talking about stargazing. So a star map or star chart is a picture of the sky at one time and one location. It's essentially a snapshot of the celestial sphere for any time and anywhere. The circumference of the picture is the actual horizon, and its center is the zenith. The lower half of the picture is what you would be able to see were it at night. So please, 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 try to review this at home on your own time, whether you draw it or make one in Excel or Word, print it out and play with it on your own. Don't really care how you choose to do it, and this will be on your exam, and I know that it is a question in your study guide that you have currently. All right, so that is the end of lecture 9. I hope you enjoyed some of it and that you learned something and that I was able to clarify some of the stuff we learned today, making it just a tad more interesting. And I will see you guys next time.